Scientists have discovered gigantic structures under the Alps. The original recordings of this underworld and the information on how the researchers were able to see under the Alps. So in this video, make sure to stay until the end so you can completely change our image of the Alps. Thank you very much everyone and welcome. We all know the Alps is the roof of Europe, with Mont Blanc as the highest mountain at 4,800 meters, idyllic lakes, lush green meadows, and purple cows. I was recently in Reit im Winkel and stomped through the mountains there, and I just think the region is beautiful. Especially because of the beer, and Kaiserschmarrn, and the white sausage. And well, I'm already digressing again. I'm sorry. Please leave a comment telling me where you have been in the Alps and how you liked it. I'd really like to know, and if you're as big a fan of the Alps as I am, then subscribe to the channel now. It's absolutely free, you'll never miss a new video again, and you'll be helping me a lot. Thank you, friends. During your mountain vacation, have you ever wondered how deep the Alps actually go? And what is underneath? No, I haven't either. But this very question has not let go of a team of researchers from all over Europe. To this end, they have launched a project that is as ambitious as the Alps are high and is called AlpArray, but first things first. Imagine the Alps like an iceberg. What we see is just the tip. Most of it is hidden below the surface. They have a gigantic root, a secret underworld that extends deep into the earth and into the mantle. But how the hell do you explore something that is hundreds of kilometers deep in the earth? Unless you want to climb into the Earth's interior like Jules Verne through a volcano, you need to bring out heavier artillery. And this is where the researchers' brilliant idea comes into play. They simply used earthquakes as a kind of cosmic X-ray machine and listened in to the natural tremors that are constantly happening somewhere on the planet. Dr. Caspar Fischer from the Seismological Observatory in Bochum explains it this way. Earthquake waves are like sound underwater. They move at different speeds in different materials. So if we measure the speed of these waves, we can easily draw conclusions about the rock they have passed through. But for this trick, you need more than just a few measuring devices. You need a whole army of them. That's why the researchers have set up a network of, drumroll please, 600 seismometers. These highly sensitive devices are distributed across the entire Alps, like Smarties on a muffin. Delicious muffin. So, these are 600 electronic ears that constantly listen to the Earth. That are permanently listening to the Earth. And these seismometers are not standing obediently in laboratories. The researchers have hidden them in the craziest places, in old castles, abandoned waterworks, schools, and even buried in the ice of glaciers. The main thing is that they have electricity and are protected from wind and weather, and now it's getting exciting. These devices record continuously, day and night, in sunshine and snowstorms. They wait for earthquakes, and not just the mega quakes that shake cities. No, they also register the tiny mini quakes that we humans cannot even perceive. Smaller earthquakes that can be evaluated happen almost every day, says Dr. Fischer. Each of these quakes sends waves through the Earth that are captured by the seismometers. It is as if the researchers were listening to the heartbeat of our planet. But how does it all work? Imagine you drop a stone into a mountain lake. The waves spread out in all directions. It's the same with an earthquake. The waves race out from the epicenter in a circle and move faster or slower depending on the material they have to push through. Now the researchers overlay the data from numerous different earthquakes in the computer and get a virtual 3D model of the underground. We then compare the measured wave velocities with our theoretical predictions, explains Dr. Fischer. If the real values differ from the predictions, the scientists know that something down here is different than expected. Incidentally, this method bears the resounding name. Good title for the next Harry Potter book. Harry Potter and the Secrets of Seismic Tomography or something like that. Basically, it's the same as a CT in the hospital, only for Mother Earth. Instead of radiation, the geologists use seismic waves to create an image of the planet's core. Pretty wild, right? And what have our scientific moles brought to light now? First of all, their measurements confirm. The Alps do indeed have a colossal root. This root consists of lighter rock and, like an inverted mountain, extends deep into the denser mantle, and this has led to some surprising insights. The textbook theory says that when the old European continental plate was born, it dutifully submerged under the Adriatic plate, an offshoot of the African plate. But the new data show that Mother Nature did not stick to this simple script. Dr. Fischer says, according to the standard model, Europe subducts under the Adriatic plate. But the reality is much more complicated. Maybe in some places it's the other way around, or there's a wild mess. With others among the Alps, it feels like being in a tectonic washing machine. Okay, I know my comparisons sometimes fall short. Regardless, the researchers have also discovered that the route of the Alps is anything but uniform.
In some places, it extends deeper into the mantle than in others. This could explain why the Alps have such a range of heights. It's as if the mountains had underground stilts of different lengths.
But the data also reveals zones with unexpectedly slow earthquake waves deep beneath the Alps. This could indicate melted rock, perhaps even dormant magma chambers. Don't worry, that doesn't mean the Alps will mutate into volcanoes tomorrow. But even beneath a seemingly stable mountain range like the Alps, there is turmoil in the underground.
And a discovery in the eastern part of the Alps is particularly exciting. Here, the researchers have found a complex structure that they call the Adriatic slab. This is part of the Adriatic plate that extends deep into the Earth's mantle. This slab is not continuous, but has gaps and deformations.
This suggests that the collision of the plates here was particularly intense and is still ongoing. In the western part of the Alps, however, scientists have discovered something quite different. There are signs of a so-called slap detachment.
This means that part of the subducting European plate may have broken away from the rest of the plate and is now sinking like a broken anchor. This process could explain why the Western Alps have been rising faster than other parts of the mountain range in the more recent geological past. The researchers also made a surprising discovery under the Central Alps. Here, the data show a zone with particularly low seismic velocities at a depth of about 80 to 110 kilometers.
This zone could indicate partially melted rock. Such melt zones can play an important role in mountain formation,
as they influence the movement of tectonic plates. And another fascinating find is the discovery of so-called mantle upwellings under the Alps. These are upwellings of hot material from the Earth's mantle.
These upwellings could explain why some parts of the Alps are rising faster than others. It's a bit like pushing up from below against the roots of the mountains. These research findings also shed new light on the formation of the Alps. Until now, we thought that mountain formation was primarily due to collision
of the European and Adriatic plates, but the new data suggests that deeper processes in the mantle also play an important role. The Alps are therefore not only the result of a superficial collision, but of a complex interplay of forces from different depths of the Earth.
Particularly exciting is the discovery of strong speed contrasts in the Earth's crust beneath the Alps. These contrasts could indicate ancient rock formations
that were lifted up during the formation of the mountains. And these findings are not only a feast for geologists, they also help us to better understand the formation and development of mountains in general. This is important because mountains are real all-rounders. They influence the climate, regulate the water balance, and as natural boundaries, determine where animals and plants live. On top of that, this knowledge could help to predict earthquakes more precisely in the future.
The better we understand the underground architecture, the more accurately we can estimate where and when the Earth will dance the Zumba again. This is especially important in a region like the Alps, where millions of people live.
But the significance of this research goes far beyond the Alps. The methods developed here and the knowledge gained can also be applied to other mountainous regions in the world. Imagine if we could examine the underground structure of the Himalayas or the Andes in just as much detail. That would be super exciting. Furthermore, the research helps to better understand the long-term development of the planet. The processes we observe under the Alps have been going on for millions of years and will continue to do so in the future. This shows us that the Earth is not a static bulb, a dynamic planet full of changes.
It is also madness that we can use earthquakes to shine a sort of flashlight into the interior of the Earth, and that beneath the majestic alpine peaks lies such a complex and fascinating world. As soon as the researchers find or unearth something exciting, you will learn about it here. First, if you don't want to miss an update, press the subscribe button and activate the bell.
Let's travel from the Alps to the North Pole. The magnetic North Pole is behaving very strangely and is changing its position faster and faster, and now it is racing towards a supervolcano under the Arctic.
What this could mean for us, and what happens when the magnetic pole and supervolcano meet, you will find out in the video displayed. Be sure to click on the top right. It's really very exciting. And if you click on the bottom left, you will go to my space shop where you can get the shirts from the videos, fluffy plush planets, and much more. Leather purchase greatly supports my work. Otherwise, I would say see you in the next video. Take care, guys.